surveying and surveyors often use multiple right triangles in order to calculate and determine certain distances when it comes to surveying the land. So a surveyor approaches the North Saskatchewan River here in close to Jasper, Alberta, and wants to determine two things. First of all, the width of the river and the height of the bank. One of the first things he does is he measures the distance between a couple of points along the bank where he is standing, and he measures those 2 points to be 22 meters apart. What he does next is he chooses a spot on the opposing bank, and here he's picked this tree, and using his instruments he measures a few angles. This one being 90 degrees, this angle being 58 degrees, and he measures another angle in here to be 45 degrees. So with these measures, he can now calculate the width of the river, which is down here, and he can measure the height of the riverbank. So what he needs in order to solve this length and this length is he needs to determine the hypotenuse, and he's going to have to use his other right triangle in order to calculate this hypotenuse. Once he has the hypotenuse determined, he can use that length plus his degree, 45 degree, to calculate the two unknown lengths. So looking at our diagram, we are given the angle 58 degrees, and we have an adjacent side, and we're trying to determine the hypotenuse. So if we remember our SOHCAHTOA, we know that we're going to be using cosine. We have the adjacent, we're trying to calculate the hypotenuse. So we just substitute some values now. Cos of 58 degrees will equal our adjacent, which is 22 meters, over our hypotenuse. We'll just quickly create a proportion. So after we do some cross multiplying, we have cos of 58 degrees times the hypotenuse will equal 22. And we'll isolate the hypotenuse by dividing by cos of 58 degrees. Therefore, we can cancel those out, and now we have our hypotenuse isolated. So our hypotenuse equals 22 divided by cos of 50. So after punching it in on a calculator and rounding it to the nearest tenth of a meter, we find that the hypotenuse is 41.5 meters. So we have now determined that the hypotenuse of our first right triangle is 41.5 meters. So with that length, knowing that hypotenuse and this angle, 45 degrees, we now have enough information where we can calculate this length and that length. So we are going to use cosine again to determine our adjacent side. We are given an acute angle and the hypotenuse, so now we can use those two pieces of information to calculate our adjacent side. And our adjacent side will be the length across the river. So we have cos of 45 degrees is going to equal adjacent over our hypotenuse, which is 41.5. Quickly turn this into a proportion to make it easy to calculate. So we have cos 45 degrees times 41.5 will equal our adjacent. And after we punch it in on a calculator, we get 29.3 meters. So now we have just determined the width of the river to be 29.3 meters. So now to determine the height of the bank, we are going to be trying to find the opposite side of the angle 45 degrees, so therefore we're going to use the tangent ratio, which is opposite over adjacent. So we have tan 45 degrees equals our opposite over our adjacent, which we have just calculated to be 29.3. Now we're going to quickly turn this into a proportion to make it easier to calculate. So we have the tan of 45 degrees times 29.3 is going to be our opposite side. After we punch it in on a calculator, we get 29.3 meters as our opposite side. Tan 45 actually equals 1, so we know that 1 times 29.3 will be 29.3 meters. So according to our measurements, the width of the river is the same length as the height of the bank.